formula gives us a relation between object distance, image distance, radius of curvature and focal length, and that relation is 1 by v plus 1 by u is equal to 2 upon r, which is also equal to 1 by f. I know that u, object distance, would always be negative for concave or convex mirror. So u is always negative. But r and f depends on the mirror I'm choosing. For concave, r and f are negative, and for convex, r and f are positive. If I manipulate this equation to get the value of v, because u already is known, I know the location of the object. So 1 by v is equal to 1 by f minus 1 upon u. Further solve it, you'll get u minus f over here. Invert it, you'll get v is equal to uf upon u minus f. Now u is negative always, f depends on the mirror I'm choosing, and again here also. For the case of concave mirror, for concave mirror, f is negative, u is always negative, which means f into u is positive. U can take two values. Either this u thing could be greater than focal length magnitude wise, which means object is away from focus, or object is before focus. If object is farther from focus, this would return you a negative number. Why? Let's take a situation. If this is your concave mirror, and if this is my f, and if this is my u, naturally f can take values like -3 or -4 or -5, and if u has to be greater than this magnitude wise, it would be -4 or -5, -6. -4 minus of -3, this would give you a negative number, in this situation -1. You can check it for different values and get an intuitive idea of what exactly it's happening. So this is negative when object is farther than focus. Positive upon negative is equal to negative, which means if object is kept away from focus, farther from focus, my image, sign of image distance would also be negative, which means it is to the left of pole. I mean the same side as the object was kept. But what will happen if object is before object kept before f? If object is kept before f, this would return you a positive number. So positive upon positive would give you positive. So in this situation, your object would be formed to the right of pole, or to the right side of concave mirror, to this side. What happens in convex mirror? Let's do the same analysis for convex mirror. For convex mirror, f is positive, u is negative, which means the numerator is negative. What about the denominator? F is positive, minus of f, this makes it negative. So minus f thing is negative, but u is also negative. So negative of plus negative would give you negative. So this is always negative upon negative. So this is positive. So for the case of convex mirror, image formation would be always to the right of the pole or to the right side of the mirror. And for the case of concave mirror, it depends on the location of object, whether it is before f or farther from f. Now, if we know this, we can have an idea with this formula about the image position. Now this has been done taking into consideration a point object. What happens if the object is not a point object? Yeah, but before I do that, let's have a quick check. Can you test this formula if the object is kept at infinity? If the object is kept at infinity, all my rays which would come, they would actually be making 0 degree with them, 0 degree angle between them, or rather, in other words, just put u equal to infinity. You will get f is equal to, rather 1 by v is equal to 2 by r, which means 1 by v is equal to 1 by f, which means v is equal to f. And when I see that rays are coming from infinity, they're making small angle between them. Why? Because if this is your concave mirror and this is your object, so all the rays which can come, this is the maximum angle they can subtend. If you remove the object from here and keep it farther away, now your angle reduces. So as you move this object farther away, this angle has to reduce. And if you keep this object at infinity, very far away, this goes to 0, which means all the rays would be parallel. And we have read this in our ray diagrams that all the parallel rays which are parallel to the principal axis, would intersect at focus. And that is given by this formula 2. Put u equal to infinity, this vanishes away, 1 by v becomes 2 by r, which means v is equal to r by 2 or v is equal to f. So with this analysis, let's jump on to the discussion when the object is having some kind of magnitude, as in it's not a point object, it is having a dimension, it is having an elevation. So let's say this is your concave mirror. Principal axis, this is your object. I can say this is A, B. I've just written O for your understanding that this is object. There's no need for this O actually. This could be your C and this could be your F. A ray which is parallel to this principal axis would intersect the focus after reflection, and a ray which is passed through the center of curvature would just retrace its path because it is normal incidence. This is the point where both these rays are meeting after reflection. So this is the image of your A. I can write A dash. Similarly, this would be image of B, B dash. Over here, draw one another ray. Now we have two triangles. This is your pole. I'll read out these triangles for you. The bigger triangle, or rather the triangle which is on top denoting the object. This is your P. This would make some angle over here, angle of incidence, and the same angle would be subtended below. I'll draw that triangle too. This is P. This is A dash. This is B dash. This is also I. This is 90 degree. When this is 90 degree, so the other angle has to be the same, which means triangle ABP and triangle A dash, B dash, P are similar to each other. If these two triangles are similar, I can simply say that AB upon A dash B dash is equal to this thing PB upon PB dash. What exactly is PB? PB is the magnitude of object distance, which is minus u because u is negative. Similarly, PB dash is the magnitude of image distance. This would be minus v. What about AB and AB dash? A dash, B dash. AB is the magnitude of object length. It would be equal to, just write HO denoting object height or length. A dash B dash is the magnitude of image length or image height. But this is below, which means my measurement would give me a negative value according to sign convention, which means I'll write a minus HI. If I take these two things, the leftmost extreme and the rightmost extreme, what I will have is HO upon HI with a negative sign is equal to this thing, minus goes away, U by V, which means HI by HO is minus V by U. I have just inverted this and multiplied with a minus sign. What is this? This is the ratio of image height to object height. This is also known as magnification. Magnification M is also known as HI upon HO, which is minus V by U. Again, we have derived this relation keeping in mind the concave mirror situation. But this is equally true for the convex mirror also. The reason being, we have taken the sign convention into consideration and we have not generalized anything. We have taken very specific situation and this is a result of that. So this is your magnification, minus V upon U. I also have the value of V. If I substitute this value of V over here, I can get magnification as FU upon U minus F into 1 by U with a negative sign. This gives you U gets cancelled away. You have a minus F upon U minus F. I'll write this thing again for you. So this is the magnification formula for a concave or a convex mirror, both. Now if you analyze this, for a concave mirror, this would return a positive number. What about this denominator? Denominator would be negative if object is farther from F. So positive upon negative would give you negative, which means magnification is negative. What is negative? What does negative mean over here? Negative means that the object would be inverted. So if the object is kept away from focal length, your magnification would be negative, which means it would be inverted. But if it is kept before F, it won't be inverted. It would be erect. What about convex mirror? For convex, it's always positive, the sign, which means magnification is always positive, which means it would always be erect. What about the magnitude value or magnitude thing? Mod of M is simply mod of F upon mod of U minus F. If I talk about convex mirror, for convex mirror, this thing over here is always going to be less than mod of F. So for convex, M is always less than 1. I'll say it again. This thing is always greater than F. Sorry, this thing is always greater than F, not less than mod F. So for a convex mirror, mod of F is less than 1 always. And For concave, mod of m depends, but if you take this situation, object kept before f, this would be greater than 1. Concave if u, mod of u is less than mod of f. What does this mean? Mod of u is less than mod of f means this is before focal length. So in case the object separation is less than focal length magnitude, I'll have a magnification greater than 1. And for convex mirror, I will always have magnification less than 1. And this is the reason convex mirror is used as a rear view mirror in your cars, vehicles, and there's a reasoning to this. I need a wide field view. So if magnification is less than 1, larger objects would be condensed or rather shrunk to smaller sizes. So I can have a wide field of view. And that's why in rear view mirrors, you would see something like objects in the mirror are closer than they appear. Because what happens is your brain has got an inbuilt image processing system. So whenever rays come to your eyes, you have signals and those signals are interpreted as an image. So whenever you see images which are very, very small, but you understand, your brain understands this is a truck or a car, this cannot be this small. So you automatically deduce from it that these objects must be very far away from me. But this is not the case. This is just the handiwork of your convex mirror. So that's why it has been mentioned on the rear view mirrors that objects in the mirror appear farther than they really are, or rather objects are closer than you actually see them than they appear. For the case of concave mirror, if you take mod u less than mod f, mod m is greater than 1, where it can use this? In the case of shaving mirrors or dentist mirror or beautician mirrors, in which you need magnified images for a very small area, because I can't afford to stray away from perfection. If you have to trim your mustache or a beard or get your eyebrows properly done, you need a good perfect image of a very small area. So you need a concave mirror. So concave mirror can be used for a beautician mirror, shaving mirror or dentist mirror, and convex mirror is used for your rear view mirrors.